Here's an interesting problem. We have a circle with a square inscribed, and here we have a square with the circle inscribed. And we're going to look at what we want to do is we want to solve for the area of each circle, okay? And we're not taking the area of the square out, or in this case, the difference between the square and the circle. Just the circle itself, how much area is taken. And this is the same square. You'll have to excuse the bad drawing, but the square has a length 2 here at the top. The square has a length 2 at the top. It's given that they are squares. So how do we go about finding this? Okay. So the first thing that we can do, let's start here with the circle that is on the outside. So since it's a square, we know that this is 2, this is 2, and this is 2. All 4 corners are 90 degrees. And so what I can do then is I can calculate this diagonal, okay? That diagonal will be the circumference of the square. And I know that since the circle, or the square is inscribed in the circle, then I know that this is the midpoint. The diagonal will pass directly through the midpoint as it does in a square, no matter which diagonal that we look at. Okay, so I want to find this distance here. I'm going to use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. So this is going to be 2 squared. We're looking at this leg and this leg. Plus 2 squared is equal to c squared. 2 squared is 4. 4 plus 4 is 8. 8 is c squared, which means c is plus or minus the square root of 8. In this case, plus, since we're dealing with a distance. So this is the square root of 8. That's that distance right there. Okay. The area of a circle is pi times the radius squared. This diagonal is also the diagonal of not only the square, but also of the circle. And so the radius would simply be the diameter divided by 2. So the diagonal and the diameter are the same length. So we can replace that with radius with square root of 8 over 2. Whoops. Okay. And then we're going to have the square root of 8 divided by 2. Then that is going to be a quantity squared. Okay. So now I could take that squared and apply it to both the top and bottom of my fraction. All right, so we have pi. The square root of 8 squared is just 8. And 2 squared is 4. 8 divided by 4 is 2. So this is 2 pi, or pi times 2, which we can reverse this to 2 pi. So that is the area of this circle here. Now what I'm going to do is jump down to this circle here. Now this is different. The diagonal here would actually stretch outside the circle itself, so that's not really going to help us. So if we could find out what this diameter is here, and since it's inscribed, we know that the halfway point here and here is where the circle would cross. So this distance here would be 1. This distance here would be 1. So that would give me the radius right there is 1. This diagonal here, or I'm sorry, this diameter here would be the same length here, which is 2. This is the same square. All 4 sides are right. All sides are 2. And so my radius is 1. I use the same equation, pi times radius squared. That's pi times 1 squared. 1 squared is 1. Pi times 1. So it's just pi. So what's interesting is if you have the same square and you put the circle around it and the circle inside of it, the area of the circle around it is twice as big as the area of the circle inside.